All right, we're back. I don't like my voice, so I'm playing around with it. Let's see how it works. Okay, we are going to... Let me erase that. We are going to find and sketch the gradient field. Gradient of f, where f of xy equals the square root of x squared plus y squared. Okay, so let's find the gradient field first. The gradient field is just taking the gradient of that expression. So, partial with respect to x of x squared plus y squared is going to be very similar to the last problem. This is raised to the 1/2. So we're going to have 1/2 times 2x for the derivative of this inside divided by x squared plus y squared in a square root in the denominator. This, of course, simplifies to, with the 2's canceling, so it, of course, simplifies to x over, I'm going to write it r, even though we know it's the square root of x squared plus y squared. Now, that was just the derivative with respect to x. We also have, in this case, this is a two-dimensional, so we're going to also have the derivative with respect to y, a square root of x squared plus y squared. I like these problems because they're very symmetrical, and I don't have to do much once I've done the first one. I just know it's going to be now y over r. Okay, so, gradient of f is going to equal, I'm going to put all of that in like parentheses, vector notation, and just write it as 1 over r xy. So that's the gradient field. Let's sketch it. That's what we're trying to do as well. So, erase that. Let me try that again. Okay, so now, when x and y are both 0, there's nothing going on. So we're going to put a little sort of hole there, okay, because at 0, it's not doing anything. Now, let's take a look. What I like to do, sorry, I'm trying to deepen my voice, is at the point 1, 0, gradient of f is going to be, plugging those in, 1, 0. So at 1, 0, we're going to have a vector pointing out like there. Okay. Now, that's actually going to happen for any point. So if I go to, let's say, 3, 0, gradient of f is going to be 1 over 3, 3, 0, which is still the vector 1, 0. So we go, say that's 1, that's 2, that's 3, and we're going to point a vector that goes 1 to the right, like so. So we can see that along this line, that's what the vector field looks like. Any vector along this axis is going to look that way. Any vector on this side is going to look this way because it's going to go in the opposite direction, right? If I have negative 1, 0, okay, the vector field is going to be negative 1, 0. And now we're treating it as a vector. Okay? I have the same stuff going on here on that axis and on that axis. Okay, now let's try, for instance, let's look at what happens at 1, 1. At 1, 1, remember, our vector field is 1 over r xy. So that means that we're going to have 1 over square root of 2. Let's write it this way, 1, 1. Or square root of 2 over 2 1, 1. Now, square root of 2 over 2 is 1.4. Let me just double check that. Nope, it's actually 0.7. So at 1, 1, I'm going to have a little bit of a shorter arrow. Okay. You could probably guess it's going to do the same thing no matter where, right? So if I have at 2, 2, it's going to be 1 over now 2 root 2 to 2. So at 2, 2, it's going to be like that, a shorter arrow. So you have shorter arrows there. Okay, and you could just do this everywhere. And you'll see that the vector field here basically pushes everything away from the origin. Okay? So the key point, you find the derivatives. To find the vector field, you plug in the point you want to look at. You just plug it in there, and then you draw a vector at that point going in the direction of the vector. So at 1, 0, you draw something going in the direction 1, 0. Okay? All right, let's see. I think I have another example. Let's pick one from the book. Let's find a vector field. Ooh, sorry about that. Let's draw the vector field. We're going to draw, let's take y, x minus y. Okay, so we are actually now here, we're actually given what the vector field is. We don't have to find it as a gradient. Okay, so let's draw our axis again. Okay, and again what we have to do is just pick some points and start finding the vector field. So at 0, 0, it's 0 again, right? When x and y are both 0, it's 0. Let's pick at the point, let's take 1, 0, just like before. What's happening there? Well, our vector field, this is actually called F. I put an arrow over it. The book makes it boldface. So at 1, 0, it's going to be 0, -1. Okay, that zeros that y, x minus y, actually, that's going to be +1. So, what's happening at 1, 0? Your vector field is pointing up. Okay. How about 0, 1? At 0, 1, we get 1, -1. That time I think it's right. So at 1, 1, we go to the right 1 and down 1. Okay. Let's try another. Let's do 2, 0. 2, 0, you're going to get 0 for y, 2. So that means that at 2, you're going to get an arrow that's twice as long as the one at 1. Okay. How about at 0, 2? Plugging that in, we're going to get 2, -2. So here, it's going to go right 2, so it's going to be this arrow. Oh, this is an ugly vector field. Okay, and then you just pick points and draw arrows. Okay, this is something that you would probably do on a computer. Okay, so we won't spend too much time on that because really that's not the point. That's not super interesting. Okay, all right, that should be it for 13.1. See you guys in the next video.